Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 12, 2026, about 2 weeks ago. It introduces a unified framework that seamlessly combines video generation, editing, and animation, drastically reducing the confusion between different speakers in complex multi-person scenes. The paper is titled DreamID-Omni, Unified Framework for Controllable Human-Centric Audio-Video Generation. And as we'll see later, the results for keeping voices synchronized with the correct face are really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 provides a comprehensive showcase of the framework's 3 main capabilities. The top section demonstrates reference-based audio-video generation, where the model creates entirely new scenes using just reference photos and voice clips, even handling complex multi-person dialogues with distinct characters. In the bottom left, the framework tackles video editing, allowing users to swap faces or entire figures in source footage while maintaining consistency. Finally, the bottom right illustrates audio-driven animation, where a static portrait is brought to life and synchronized with a driving audio track. Figure 2 outlines the framework architecture. On the right, the symmetric conditional diffusion transformer processes video and audio in parallel streams that sync via cross-attention. To prevent speaker confusion, the structured caption panel on the left assigns unique tokens, like sub1 to distinct characters. Meanwhile, the Syn-RoPE blocks in the center align these identities temporally. Finally, the bottom panel shows the 3-stage training curriculum, progressing from simple reconstruction to complex multitask learning. Table 1 summarizes how the framework unifies these capabilities by simply toggling the input signals. For human reference audio-video generation, it uses text, identity images, and audio timbres to create new scenes from scratch. The second row shows that adding a source video switches the mode to human reference video editing, modifying the identity within existing footage. Finally, for audio-driven video animation, the system uses a driving audio track to animate the reference identity's lip movements. Alright, Table 2 compares performance on the reference-based generation task. The top rows list video-only baselines, while the middle section includes joint audio-video systems like WAN 2.6. The standout result appears in the bottom row with the proposed method. Specifically, in the far right column for audio-visual consistency, notice the speaker confusion score of 0.08. This is significantly lower than the 0.38 of competitors, confirming that the model successfully prevents voices from being assigned to the wrong character during multi-person dialogues. Well, Figure 6 visualizes exactly what happens when you remove these key components. In panel A on the left, we see a multi-person scene. The top row shows that without structured captions, the model gets confused and swaps the identities, marked by the red crosses on the faces. In the middle row, removing the synchronized rope fixes the faces, but now the audio waveforms are marked with errors because the voices do not match the speakers. Finally, panel B on the right confirms that the full multitask training scheme is necessary to generate high-fidelity images that actually look like the reference. So, Table 5 quantifies these ablation results. If we look at the row without structured captions, labeled with OSC, the speaker confusion score on the far right jumps to 0.26. This confirms that without explicit captions, the model struggles to assign the right voice to the right face. Meanwhile, the top row shows that removing the synchronized rope causes timbre similarity to drop sharply to 0.21, indicating that these embeddings are crucial for preserving voice identity. Wrapping up, the biggest takeaway here is how DreamID-Omni unifies 3 distinct tasks: generation, editing, and animation, without sacrificing quality. By solving the persistent issue of speaker confusion through dual-level disentanglement, it offers a robust tool for creating complex, multi-character narratives. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.